Hello and welcome back to another episode of Teach Me in 10. In this episode, we're joined by Phil Taylor, Marketing Lead of Food and Environmental at PerkinElmer. Phil will guide us through the essential principles of rugged workflows for complex food testing, workflows built for reality, not just ideal samples. He'll show why traditional methods break down with tough samples and how rugged workflows deliver stable, reliable results.
In the next 10 minutes, I want to talk to you about how modern food testing is changing and why it needs to change. Today's labs aren't working with ideal samples. They're dealing with complex, high-matrix foods, global supply chains, and increasing regulatory pressures. In this session, I'll focus on one key idea, ruggedness. Not just sensitivity, but workflows that keep delivering reliable results when samples are messy, matrices vary, and volumes are high. I'll show how PerkinElmer designs rugged food testing workflows that are built for reality, not ideal samples, and how that helps labs protect the global food supply with confidence. When we talk about complex food, this is what we mean in real life. On the far left, high-fat dairy products. Fats co-extract, contaminate systems, and mask target analytes. In the middle, spices and botanicals, packed with pigments and natural compounds that interfere with detection. Then, processed and heat-treated foods like meats, where the matrix has been chemically altered by cooking or smoking. And finally, multi-ingredient products like juices and beverages, where sugars, colours and additives all combine. Individually, each of these is challenging. Together, they represent the reality of modern food testing. This is why complex food doesn't just need sensitive testing, it needs rugged testing. When testing isn't rugged enough, this is what labs typically experience. Matrix interference and inconsistent recoveries are obvious. But just as common is the need for constant manual adjustment and troubleshooting, especially with complex samples. Methods that work perfectly on simple matrices suddenly become very sensitive to day-to-day variation or operator technique, and that quickly turns into real consequences. False positives that trigger investigations, false negatives that create risk, repeated reruns that slow the lab down, and ultimately audit findings or loss of confidence in data. This is where complexity stops being a technical challenge and becomes a business and compliance problem. When we use the word rugged, we mean workflows that continue to perform even under deliberately challenging conditions. In internal PerkinElmer studies, we see tens of thousands of continuous injections of high matrix food samples, including fats, proteins, and pigments, with stable performance and minimal cleaning. We also see ruggedness in workflows that intentionally reduce sample cleanup, such as the simplified blended inject approaches, while still achieving regulated limits. And importantly, ruggedness isn't demonstrated on one food. It's shown across many matrices over time, and often with minimal manual intervention. That's what gives laboratories confidence in real-world testing. One of the most important principles of rugged food testing is recognizing that more cleanup doesn't automatically mean better results. On the left, you see a conventional catcher-style workflow, effective but time-intensive with multiple handling and cleanup steps. Each of those steps introduces time, consumable cost, and potential for variability. On the right is a blend and inject approach. The key difference isn't just speed, it's simplicity by design. Fewer preparation steps mean fewer opportunities for handling errors, inconsistent recoveries, or operator variability. In this example, using a high-fat matrix like avocado, the workflow is deliberately simplified, while still maintaining stable performance. That's why less cleanup doesn't mean less confidence. It often means more consistent results, especially in complex food matrices. This is a good example of how ruggedness is engineered into the workflow from the start rather than added later through controls or corrections. This slide shows what rugged multi-residue testing looks like in practice. The key message is right at the top. Rugged workflows maintain both selectivity and sensitivity in high matrix foods. The examples here deliberately use some of the most challenging food types, high-fat matrices like avocado and highly pigmented matrices like beet. These are exactly the samples that typically cause matrix interference, poor recoveries, or the need for additional cleanup. What matters isn't the individual compounds, it's the behavior of the workflow. Even with simplified preparation, we still see clear, well-defined target peaks retained in these difficult matrices. This tells us the workflow is selectively tolerant of matrix background. It can handle complexity without losing confidence in results, and that's the point of rugged design. When sample complexity is unavoidable, the workflow is built to tolerate it, not fight it with more and more cleanup. This slide is about how ruggedness holds up over time and not just on day one. The data shown here comes from a deliberately demanding PFAS study across challenging food matrices, including fatty and pigmented samples, as well as animal feed. Importantly, the workflow was intentionally stressed. The final SPE cleanup step was omitted to maximize matrix load in the extracts. What you see in these plots is a stable analytical performance across more than 20,000 continuous high matrix injections. Both the raw response and the internal standard corrected response remain consistent as injection numbers increase. This is a critical distinction in regulated testing. Sensitivity on the first day is important, but rugged workflows are proven by performance over time, volume, and real-world conditions. This kind of long-run stability reduces corrective actions, minimizes downtime, and helps laboratories remain audit-ready even under heavy sample load. So far, we've used LC-MS examples to demonstrate rugged workflows under stress. This slide is here to make an important point. Ruggedness isn't limited to one technique. It's a workflow principle that applies just as strongly to inorganic food testing. Elemental analysis often faces many of the same challenges we've talked about today: fatty, salty, protein-rich, and particulate-heavy food matrices, long analytical runs, and high sample volumes under regulatory scrutiny. The example shown here is a 12-hour stability study across plant-based food samples, where CCV recoveries remain within acceptance criteria over time. The key message isn't in the individual elements, it's the behavior of the workflow. Rugged inorganic workflows are designed to control matrix-driven interferences, maintain accuracy over long runs, and support routine, regulated testing with minimal intervention. The technology may change, but the definition of ruggedness stays the same. To wrap up, the common thread throughout this session is ruggedness. Modern food testing isn't just about achieving low detection limits on clean samples. It's about delivering consistent, defensible results when matrices are complex, volumes are high, and regulatory pressures are real. We've seen that rugged workflows tolerate matrix complexity, and they hold up over time and reduce dependence on constant cleanup or intervention. And importantly, those principles apply across food testing, from inorganic contaminants and PFAS to elemental and inorganic analysis. Ruggedness isn't a single instrument or technique, it's a workflow philosophy, one designed for reality, not ideal samples. And that's what enables laboratories to test with confidence, even as food systems continue to evolve. Thank you.
Thank you for joining us for another episode of Teach Me in 10, brought to you by PerkinElmer. PerkinElmer is a global leader in food testing innovation, offering rugged, real-world workflows that deliver reliable results, even in the most complex food matrices. For more information and helpful resources, including application notes and product details, check out the links in the description. And if you enjoyed this episode, don't forget to like and subscribe to catch all of our latest Teach Me in 10 releases. Bye for now.